Hello. So in this lecture, first I want to explain the property, very important property, circular convolution first, and then symmetry. Because I think what is the utility of symmetry will go to understand after getting the what a circular convolution is. After getting that, you will understand what is the necessity of circular symmetry. Though in books they used to cover it first after they go for circular convolution, I just want to go for a bit different way. Now, what is circular convolution? Now, we know we are very much familiar with this word convolution. We have done it in previous. That was basically linear convolution. We have covered linear convolution. What is linear convolution? When the sequence of two signals x1 n and x2 n, they are aperiodic. They are basically discrete two sequences and they are aperiodic sequences. Then we will get the convolution called linear convolution. But we know as per DFT, using DFT, what we are getting xk that is becoming periodic. So, when you are going for a DFT of a sequence, you are getting the frequency domain periodic, frequency domain signal periodic. So, suppose you have a xk and suppose you have a h of k. Okay, so you have a xk and h of k. Both of them are periodic. And when you are going for IDFT of these signals, what type of signal you are getting? You are getting the time domain signal is actually also periodic. That means the x of n is becoming periodic and h of n is also becoming periodic. So now when you are going to convolute, you convolute between two periodic signals. There will be a big difference between a linear convolution and circular convolution. So we will going to call a convolution circular convolution when it is actually convoluting two periodic sequences. Okay. And in case of DFT, as the property of DFT imposes periodicity, as we have discussed in the previous lectures, in the last property we have also discussed that it is actually imposing periodicity in the small n and k pair, in the endpoint DFT pair of n and k. That's why the frequency domain signals as well as the time domain signals are becoming periodic. Now in time domain signal, if they are actually acting with each other, that is convolution. So this convolution will not just similar to the linear convolution because the sequence is becoming periodic. So it will be known as circular convolution. Okay. So this is the circular convolution. Now, what is the circular symmetry? Okay. I am going to discuss it in the consecutive lecture.